Hello and welcome to this course, GIS for Beginners. I am Dr. Alamayo Mideksa. In this session, I will teach you about GIS data structure. So the GIS data model. What is a GIS data model, or what is the GIS doing? As you can see at the bottom, a real-world representation here. The buildings, the parks, the roads, and the rivers. So what a GIS does is an abstract representation of all these real-world features into some models. For example, this is representing as a zone. So each part of, for example, this urban area, or just, buildings are represented in this zone, and some of the vegetation covers here are represented in this zone. Another way of representing the real world is elevation. So altitude variation can be modeled here. High altitude, low altitude can be representing the real world. Another example is parcel or cadastral mapping or street map, and address, geocoded address, like as a point data. For example, here you can see the different houses here, as you can see here, modeled using a GIS or geocoded address data. So overall, GIS allows the geographic features in a real-world location to be digitally represented and stored in a database. It also allows these features abstractly represented in a digital map or even in a paper map. So technically, this is how a real world is represented, like as a base map or a satellite imagery. A land cover might be represented, or demographics or population or wetland data, topography again, some zoning or parts. So these are all models, abstract representation of the real world, layers of information. So a GIS data model, can be represented as overlay of layers, and because of that, we can identify either spatial patterns or temporal trends over time, and this eventually can help us to better understand the environment. Another representation of GIS data is a spatial and attribute data. Spatial data answers question of where it's regarding to location here, whereas attribute data represents question about how, when, and what. A raster and vector data representation is another key model in a GIS. For example, here's a real world, and then it can be in a GIS, it can be either represented as a discrete vector data representation, which is polygon, line, and points, whereas in another model, in a raster data representation, which is a matrix of pixels, the smallest area unit that's represented as a feature. Another way of looking at the raster and vector data representations, this is the real world. For example, some house, forest, river. In a vector data representation, this house is represented as a point, and then this, trees are represented as polygons, and then the river is represented as connected dots or a line feature. Whereas in the raster data representation, it's a matrix of pixels, square grids that represent the real world, whereas the river is represented as a combination of pixels forming a linear pattern. So does the trees, and a house is represented as a single pixel, as compared to a point in a vector data representation. Comparison of the vector and raster data. The raster data is the most common data format, and it's easy to perform mathematical and overlay operations. And satellite data is easily incorporated, and it mostly better represents continuous type surface data. Whereas the vector data advantage is especially for accurate positional information that's best for certain district or thematic features like roads, buildings, things like that. And it's compact data storage requirements.